A very warm welcome for all the viewers. My name is Sanjit. I'm from RMK Engineering College in Tamil Nadu. And here's our problem statement. Identification of algorithm from the given dataset using AI ML techniques. So the thing is, we have lots of data in our personal devices and we will have to communicate it through a network. And when we do so, we need to make sure the data is secured and is not accessed by people that are not authorized by us. In order to do that, we use something called as encryption. Through encryption, we modify the language of the data in such a way that only the intended recipient will be able to decrypt it and understand the actual text or actual data. So here the thing is there are lots of cryptographic algorithms available and each one of them has their own pros and cons. The goal is to build a machine learning model that's going to take input of an encrypted data, which is also known as a ciphertext. The NTRO has given us a dataset. We'd like to take a look on that. So this, what you're seeing, is an example of a ciphertext. This is how the data gets encrypted, and this can only be read by the intended recipient. So we need to build a machine learning algorithm that is going to take this ciphertext as an input, and it should be able to tell which cryptographic algorithm was used to create this. When we find that, we make a step towards decrypting it. Like that's the first step towards decrypting it. And this way we can ensure that we are able to bring a better understanding of the weakness in each of the algorithms. So we know how reliable a particular cryptographic algorithm is, and we know how exactly to make use of them. Let's get started. So here is our application Cryptokhan, which we have deployed it using Vercel, which is a free hosting platform, and this is an authorization platform, and I've already registered my email ID, so I'll just get started with that. Yeah. So here is a simple minimalistic device. This is designed in such a way that there'll be no confusion for the users, and I simply copy pasted the algorithm which I copied from the NTRO's database. Now let me just click the submit button. Now, as you can see, it's generating me a long tabular column of results, which is the probability rates of a particular cryptographic algorithm. Now, here I'd like to clarify that there is not an absolute way to figure out which cryptographic algorithm was used to create this. So we can only come to an estimate. That's the achievable practical thing possible. And here it is suggesting that this algorithm, this particular ciphertext, most likely could be an monomedian for about 42%, but it's not limited just to that. It could also be homophonic for about 19.86%, and tridigital for about 8.43%, and so on. As you can see, all the various probabilities, and finally, it's also telling you what it could not be. 0% indicates that it is impossible to be a plain text, which is true. It is not a plain text, it is a cryptographic algorithm, it is a ciphertext. Now I've made this, I've just pasted this ciphertext. What if I had to paste a ciphertext some couple of days ago and I suddenly need to look up which ciphertext it was? No problem. We can also go to the history page, and as you can see, this particular algorithm I tried on 12th September and it turns out to be AES 256, which is a particular algorithm that encodes everything in 256 bytes. And this is the sample, like this is the prelude of the encrypted text. Now, I'd like to delve a little bit deeper in the backend code. How exactly we're doing is it is used something called as supervised machine learning algorithm. Now, here, supervised machine learning algorithm means that when we are given an input, a large data set of input, so it has all the cryptographic algorithms and the corresponding ciphertext. We will be able to classify which ciphertext comes from which cryptographic algorithm. Here's a very simplified example. As you can see, the input data contains various fruits, and we specifically denote certain labels on certain inputs. Let's say something this looks like an apple that is red in color and round. It turns out to be an apple, and this is something that looks orange in color, it turns out to be an orange, and something that's yellow and long, it turns out to be a banana. Now, using all these data set, we train a machine learning model and given an input text with something like this, which we just gave. Yeah. So which we just gave here. Now, this data set is an example for this one. Now, taking this model is going to predict an apple. It's an apple. So that's the same way we're also able to generate all these prediction results. We're able to predict what ciphertext it could be, what cryptographic algorithm it was used. And this is a very simplified example, and this is a transformers architecture model which we are using in our backend code. I'd like to show you our backend code, and here we're using it Python, and this is something known as an attention transformer, which means it goes pretty much technically. I would like to simplify it as much as possible and just denote the business logic here. It basically works something like this. We take in the data and we perform lots of computations and we occur something known as feed forward. A feed forward is something that is based off a neural network, kind of how our human brains function. And we take all of the data and we classify it into all of the types which you are seeing right now. So that is how it works. Thank you so much for watching this video and thanks.